Evaluate limit as x approaches infinity of square root of x over natural log of x. Okay, so just from my intuitive feel here, what's probably going to happen is it's probably going to go towards infinity. And the reason I think that is because square root of x tends to shoot up faster than natural log of x. Natural log of x gets big really, really slowly. So intuitive feel, I'm like, okay, probably positive infinity. And once you start doing series convergence and divergence, you'll have a similar spider sense built up. But to show this in a slightly more formal way than spider sense, we're going to go with L'Hopital's rule. So limit as x approaches infinity of x to the 1/2 over natural log of x. To do L'Hopital's rule, we take the derivative of the top, derivative of the bottom, which would give us 1/2 x to the negative 1/2 over 1 over x, which would be 1/2. So the negative will move this to the bottom. So we'll have x to the 1/2 in the bottom, 1 over x multiplied by the reciprocal. So when you divide by fractions, you multiply by the reciprocal, which would give us x on the top. And this would be the same as 1/2 times x to the 1/2. And then we do the limit as x approaches infinity of 1/2 x, I'll say square root of x. That will give us the square root of infinity, and the square root of infinity is considered by most to be the same as infinity. So our result here, limit as x approaches infinity of square root of x over natural log of x, would be positive infinity, not to be confused with negative infinity. So yes, our initial intuition was correct. This does go off to infinity, and that's how you address this sort of problem. Yep, make sure you got everything right, or at least correct enough. And yep, looks good. Okay, see you guys next time.